Somebody gave me this mug. I forget who. Art should disturb the comfortable and comfort the disturbed. This is just plain coffee, by the way. I made the comment in the last episode that I drink a breakfast stout for breakfast each day, and I got a few comments on it, and that's actually not true. I don't drink beer for breakfast. Welcome to the Fireside Tattoo Podcast. It is a gross and dreary and thunderstormy day here in Memphis, Tennessee, in Grind City. You might hear some thunder rolling through on my mic here. It's really bad. Big thunderstorms, tornadoes, all kinds of stuff. So I'm going to try to be fast with today's intro. This is a continuation, part 2 of our interview series with Carson Hill. There are going to be several more of these. If you have not yet seen part 1, I don't know the episode number, but we called it The Problem with Rotaries, and I'll link to it. I'll put a card up here somewhere. Stop this video if you have not seen that one and watch that one first. Otherwise, you're going to be a little lost when it comes to this one, some of the terminology that we're using. We start off with a little bit of a subject change. We started talking about making needles back in the days when we actually made needles before we used cartridges. And that led a little bit to the benefits of, maybe not the benefits, but some of the value that we can extract from the old kind of tattoo mechanism, old tattoo kind of mentality that we could bring and probably benefit from in today's modern tattoo world. But then we jump right back into to talk about digital versus mechanical give. And then we throw in a new variable in today's episode where we talk about actually adjusting needle depth and how that changes or adds another level of complication to the already complex problem of making a rotary motor have some sort of give, whether that's digital or mechanical. And I have my questions even now, going back and editing this, about if we're even talking about digital give at all. And maybe we'll revisit after we get some comments on all these episodes and address some of these questions a little bit differently. Because I might say that digital give right now is not digital at all. It's just kind of an electronic give in a rotary. I don't want to go too deep into that. It's just something I've been thinking about as I'm editing these videos. Anyways, real quickly, let me thank our sponsors. You know, you can support us. The best way to support us right now, outside of going to Patreon and making a donation, is to support our sponsors. They will give you discounts on stuff that you already buy, stuff that you already need as a professional tattooer. And then we get a little bit of a kickback, which helps us to continue to make these videos and hopefully make them at higher and higher qualities and get better production value as we go along. So very quickly, today's sponsors, first off, is Neuma Tattoo Machines, and they're offering a 10% discount on the Neuma 4. As the series goes on, you'll learn more and more about the Neuma 4 and what I believe makes it a very unique rotary tattoo machine. And if you're an artist who has never experienced coil machines or kind of like longs for some of the qualities of a coil machine, the punchiness of a coil machine, this machine is probably something you'd want to check out. I'll link to the website in the video description below. I don't believe Carson gave me like a specific, affiliate link or anything like that. You just literally have to type in the code Fireside at checkout to get the 10% off of the machine. Second sponsor, Reinventing the Tattoo. Guy Aitchison and Gabe Ripley are doing a lot of really great tattoo education content all the time. A lot of it is free, but there is a paid subscription that even without the 10% Fireside discount is only like $300 a year. So you take another $30 off of that. It is a steal. Tons and tons of great content. I do some stuff on there. I do a Monday morning drawing group, and there's some rumors going around that maybe Guy and I may put together some type of course workshop on the paid site. So that would definitely be worth checking out. I'd be super honored and excited to collaborate with Guy. I've looked up to him for a long time. Also, TSM Pro, you've heard me talk about TSM Pro before. They're offering some huge discounts. They are a tattoo technology kind of startup that's aimed at simplifying the lives of tattooers from an admin and kind of marketing, advertising, and shop management standpoint. I won't go too deep into what all they offer, but they've got some super, super cool stuff that they've introduced to me lately, and I'll link to their site so you can explore and see what all they offer and what works for you. And that's it. Let's get to this episode. I don't think I have anything else to say. I hope you enjoy it. Like I said, be sure if you haven't watched the first part, watch that first. Go back and watch that first. You may want to rewatch that because some of these episodes do get a little bit dense. This one ended up being about 30 minutes long, a little bit longer than I wanted, but it wraps up the whole digital mechanical give kind of thing before we move into the next topic, which I will, I'm just teasing you with it now because I'll tell you what it is at the end of this episode. We'll tell you what part 3 is going to be about. I don't think it thundered the entire time, but I was doing that intro. Sweet. All right. Thank you.
You know, I would also say that there's something to be said about the guys that do that. I like, as you would agree, like we both came from coil backgrounds, so I don't know if you ever made your own needles or that kind of thing.
Yeah, so every morning.
Yeah. So I would make needles for the whole shop when I was apprenticing, and I had to scrub tubes and all that stuff. And nowadays I'm thinking, oh man, I'm so glad I don't have to do that. But I'm happy that I had to do it when I did. I know what to complain about. I know what to look for when I'm using different cartridges, for example. Like I'll give you an example: Black Claw cartridges. I personally don't think there's anything as good, and I know why. I know it has to do with the craftsmanship of the needle configurations, how far up they're soldered, how they're putting those things together. It has nothing to do with the plastics and this and that. The point is that knowing how to do it makes you understand it all the more. And if you don't know how to do it, then you don't really know why a certain brand doesn't work for you.
Yeah.
And that's just one example. There's so much more to extract out of the old school mechanism of tattooing. That seems like if you don't understand all of that, then you're missing a whole lot of information to work with.
I think about, jumping on and buying cartridges now, and even coming from a needle making background, when I first started buying cartridges, when I saw things like power liner, or they were using terminology that I was like, well, what does that even mean? And it's not until you test and buy a few of those things and look at them under an eye loop and go oh, okay, that's just a looser round. I used to make those sometimes too. I didn't know I didn't call them that. But without that bit of experience, then, you're really kind of scratching your head, well, I guess I'll just buy one of everything and see. And you may never really figure out what the differences are between them.
I used to make my needles for the day, so I would, okay, what do I have to do today? I'm going to do this portrait. So I'm going to make a 7 mag and an 11 mag, but I'm not going to solder them very far down. I'm going to have the needles really loose, so part of me, I'm sure it was because I'm lazy and I didn't want to make 100 needles at a time, because who wants to do that? But the other part was I would, or at least the excuse was that I could make needles custom for each tattoo, which is something that you can't do if you're using cartridges. But I agree, power liner, it doesn't mean shit. It's just a way of branding, oh, we left the solder further back, or versus ultra tight or something like that is, they soldered all the way up and they made sure the tips were all really tightly put together. And I know how they're doing it because I had to use the little gauges to line up my tips. And so
right, yeah. And stumbling back at that, I know this isn't supposed to be a needle making talk, but that would be great. We should do a full needle making talk. I would love to. I know that I probably still have the jigs and things somewhere. I would love to set up a camera and actually try to make needles. I'm sure I would fumble through it at this point. I'm so far out of practice, but I remember ending up with happy accidents making needles. And a lot of times needles I just had to throw away. You make needles for the day and you realize wow, none of those are any good. I have to kind of tough it out. But for example, not soldering as far down or something like that. I probably first did that accidentally, and then realized oh, that's actually hold on to that needle and see what was different about that. That works better than what I normally do.
I would also guess that rounded edge mags were probably accidental. I mean, when I was making needles, I would come up with ideas oh, what about a rounded round? Like a rounded edge instead of them all being square. Because as I'm working, I'm visualizing, and a squared off mag, you got that corner. Right. And so, some percentage of the time, half of the needles aren't even touching the skin, and then some of them are going much deeper than the next one in the line, and so forth. And the same thing would be true with a round, especially if you're using a 14 round straight round. it would make sense to soften the edge of that, because you're coming in at an angle, not straight up and down.
Yeah, you're absolutely right. Why doesn't anyone make a rounded?
I don't know.
Yeah.
Why don't we?
Do you wish your rounds were just a little rounder? Of course you do. I'm excited to introduce the all-new Rounded Round from the Fireside Tattoo Network. Actually, that's not true. We ain't jumping in the needle-making game. Come on now. I do want to go ahead and jump forward in this conversation, though, just for the sake of time, and get back into this digital versus mechanical give stuff. But on a side note, if you would like us to do something on needle making, maybe you came into tattooing after, after people stopped making their own needles, leave us a comment about it, and maybe we'll try to put that together. I think it would be fun to go through and try to make needles again, just for the sake of a video. I don't want to do it like for a job or anything, but for the sake of a video, I think it'd be fun. All right, let's jump forward. Thanks.
Okay, so direct, meaning there isn't a mechanical give at all. It's just pushing the needle forward and pull the needle back. So within, direct drive machines, there's those machines with a chip and those without. And that chip really, just like we described, either adds power to keep the RPMs the same, or it doesn't have the chip, and so it just bogs down.
So in bogging down, meaning as the motor is pushing the needle forward, it's meeting the resistance of the skin, and it's slowing the motor, which in turn increases the potential dwell time of the needle, how long the needle is actually making contact with the skin, correct?
Well, not necessarily, because it's just the RPMs have gone down. So, but the geometry of that cam hasn't changed. So it slows down the whole process, but not the specific dwell time, because it's still, the motor is going to spend, the cam is going to spend the same amount of time in each position of its cycle. I would say the main difference between the two is, let's say you're running at 5,000. As you come into contact, it slows down to 4,500, or it doesn't. I actually kind of prefer that it does slow down a little bit with the contact, because if I don't want it to be, let's say I want to work at 5,000 RPMs, just as an example, I can turn my power up on my power supply, and then say it's now 5,500, and these are all just estimates. But now when I come in contact with the skin, it's 5,000-ish, right? Whereas with this chipped version, my problem with that one is that, like, I'll go in with that expectation. Let's say it's 5,000, it starts to slow it down, or I'm expecting it to slow it down, and it doesn't. Instead, it's like it just hits even harder. Then it feels like I have less control over that. But that's just my opinion. I think I'm sure some people prefer it the other way.
I think that Ty Pilata likes that boost mode. He felt like that he gets in and out of the skin faster and causes less trauma. So I'm sure that there's a reason that they make it with and without, because it's individual preferences. But so we're talking now about a direct drive. So we have a cam that's making a motion, and there is no mechanical anything that's providing cushion or giving the needle any place to go except for that full rotation that it has to make, right?
Yeah. Yep.
Okay.
Yeah. So you've got this circular cam with the needle having to go all the way to the end before it can come back. So this is the top part of its stroke, bottom, and there's no way of cutting that short. You have to go all the way down in order to come back up.
Right. And so that, if we're calling that digital give, meaning that the machine slows down, which slows the speed of the rotation, that's really not correct at all, because there is no give. It's making the full motion. Give would mean that it's cutting that motion short in some way, right? Or at least is able to cut it short in some way.
If we're going to be defining give based on what we know from coils, because that's where that word comes from. It comes from the coil world. So it doesn't seem reasonable to me to use that same word unless we're defining it in the same way, right? Otherwise, why don't want to just call a rotary a coil, because it's using a coil too, right? So if we have to be able to agree on the language so that we can understand what we're talking about. So yes, I think that that's my way of saying, that's not give. It's bogging. It's changing the speed of the motor. That's all.
So let's contrast or compare that with a rotary motor that does have some type of mechanical give, whether that's a cushion like you were showing in what I assume is the previous episode we'll drop in, or whether it's built into an armature bar or a plunger that has some type of dampening system built into it.
Yep. Okay. So now, now a couple things are happening. So the idea is, or we thought when I believe that when give was created, the idea behind it was to replicate the coil and what was happening with that, which is why we called it give, right? Because that was what, the reason that give is even a conversation to begin with is that when people started using rotaries, they were like, screw this thing, it has no give. And they were talking about their coil. The coil has give, it backs off. So what it is doing, it is accomplishing that the needle, if this is the needle, on a rotary, let's say this is the stroke, from here to here, it has to go here before it can come back. It cannot go here and back on a rotary. It has to go all the way. So with a mechanical give, we are achieving that it doesn't have to go all the way here. But because it's a rotating motor, what we're doing is we're creating this shortcut in the cam only on the part where it's touching into skin. So what was once a circle is now
kind of flattens out on one side.
That kind of a shape.
Right.
And so now if you look at, like, let's say you're tattooing 1 millimeter deep, the amount of time you spend is these two lines here. But if you look at that one, now you're tattooing the same depth, and you can see that the time frame is much longer. So that's what we talk about when we're saying dwell time. We're saying that, whereas we're doing something like this basically on a rotary. So instead of my cam having to go all the way forward like that, it's cutting the corner and then round and then cuts the corner. But while it's cutting that corner, it's crossing over. It takes time for that to happen. And the needle's in its extended position at that point. And so although you're backing off, you still want to tattoo to a certain depth. And so the needle's still in the skin. And so basically the short version of what I'm trying to say is that mechanical give is harsher on the skin than a direct drive. And that's the messed up part, because the only reason to desire give in a rotary is to reduce the amount of trauma that's being done, because we're complaining that the needle has to go all the way forward before it can go back, right? But if what we're doing is we're making it worse, then we screwed ourselves in the process. And so I would say a lot of people I've talked to that use a machine with mechanical give, they say, yeah, but I tighten it all the way. You know what I mean? So it's like, well, first of all, why do you use mechanical give if you just tighten it all the way? And second of all, it doesn't remove it. It just tightens it as much as possible. And then over time, also, it gets longer and longer. So my personal philosophy is mechanical give does not belong in a rotary at all. It makes it worse.
Another variable to throw into that is often if you have mechanical give, and so you're, instead of reaching that full kind of revolution, you're cutting that short, and it's allowing the needles to press back. If you're trying to reach a certain depth, you end up changing your needle depth setting on the machine sometimes anyways to make sure that you're still getting that full depth. And I don't know what, right, because you want it to, you can tell that you're not getting the saturation because of the give, and so you end up setting your needle depth a little further out. And I wonder, I don't know if that just throws too many variables in, but I wonder what your thoughts are on needle depth versus, as a piece of that puzzle, versus stroke and give,
Yeah, it is further complicating things, because now as an artist, you're used to a certain amount of needle coming out of the tip of your tube. Mostly that's for visual purposes. And, do you like to look at the needle when you're tattooing, or do you want to estimate where the needle is based on the shape of the tip of the tube? I've always been the type that wants to look at the needle. For like lines, for example, I can precisely line up the line that I didn't finish. I had to do it in 2 strokes. If I'm looking at the needle more so than looking at the tube. So now, like you said, if I hang the needle out a bunch, but now that last little bit is not doing anything, so it's just going to back off anyway. Now I'm working off a much smaller amount of needle, so I kind of become, I call it ride the tip. If you just barely stick it out, I'm sure a lot of people do. Mm-hmm. So you started off as the guy who rides the needle tip, and then you ended up the guy who rides the tip of the needle halfway through your line. And so, like you said, then you stick your needle way out, and now it's just an extra variable to have to deal. I totally agree, and I think it gets so complicated, and there's more. There's more complications. This is just the two first ones.
Yeah, tip of the iceberg. Okay, what's a further complication?
Well, okay, so then we talked about before we were saying the natural motor versus the chipped motor. Okay, and now we're talking about mechanical give versus no mechanical give. So now we've actually got 4 variables, and so you can mix those 4. So in other words, you can do direct with give, natural with give, or you can do natural without give. You can also do chipped with give or chipped without give. You know what I mean? So now if you're all of those variables we were just talking about, and now you add in the bog thing, right? So what happens when you have a machine that bogs down and has mechanical give? So now you're sticking a needle out to accommodate or compensate for the mechanical give, and then you're offsetting your, it just starts to become very confusing, especially for somebody who is not, somebody who from a modern era, they don't necessarily know how to translate all of that.
One thing that we've kind of skimmed over that maybe we should clarify is when it comes to things like this all results in increased or decreased skin trauma and dwell time in the skin directly correlates to that. Ideally, we want to get in the skin, poke a hole and not create a tear, and get back out of the skin as efficiently as possible. And that's what all of these variables are kind of, that's the end goal that we're looking for. So, well, let's just to simplify it as much as possible, let's use mechanical give. So if we have mechanical give, which increased, going back to your little illustration where it basically cut the top off of that circle, and we've got a flat area where almost half or 40% of this rotation is spent inside the skin. That's enough time possibly for you to move your hand and cause an actual either an oblong circle or a tear or some undesirable hole.
Yeah, right? and the interesting thing is that what we have to look at here. I wish I had like a camera to show.
Yeah.
Okay, when we're looking at this situation, and let's say we've got mechanical give with a shitload of it, and we're using max amount of give, just as it'd be a bit easier for me to illustrate what I'm talking about. So now half of the cam has been flattened out on this side, right? Where here is where it would have been, except this is where the rubber cushion exists or something like that. And so this is where it pushed the skin or whatever, the needle interacting with skin pushes this and flattens it out. So what it looks like is we're saying 50% of the cycle is in the skin, but we still want to go to a depth. Right. So let's say this is the depth that we're pushing the needle into the skin in order to make an effective mark. So actually that's this much too, right here and right here, more than half of the time, because what we really want to do here is unravel this rather than look at it as half and half. It's not looking at half circle and a half circle. We're looking at the line around the outer part. This here, this section here is not touching the skin, whereas this section here is. So if I were to lay that out, it's more like that section is touching the skin, and then whatever that distance is there, we lay that out, and that section isn't touching the skin. So it's what I'm ultimately saying is that it's more dramatic than it seems, even in those graphs. It's actually, it can be as bad, it can be, and then, okay, so then there's another layer that we haven't mentioned, and that's the stroke length. And so if we've got a short stroke length with a lot of give, now we've got an extra problem, because let's say that my stroke length is only 2 millimeters and I want to go to a depth of 1 millimeter and there's give. It's almost like at what point does the needle get pulled out? It's almost like in there so much of the cycle that it's really damaging the skin.
Well, let's go a little further into that with stroke length. First off, I guess we'll identify what stroke lengths are, what makes what is actually happening to change the length of the stroke, and then how you would choose one over another.
With rotaries specifically, or actually what I would say really quick is that with coil machines, typically a short stroke length is better for lining, right? Because your needle's moving really fast, you can make more dots in less time. So you can run through lines much quicker versus like a long stroke, it takes more time for it to go back and forth. So that's one of the differences. Not that that's what we're necessarily jumping into just yet, but that would be one of the differences between lining with a rotary versus lining with a coil. With rotaries lately, or within the past couple of years, they've started making longer and longer stroke rotaries with the intention of using them for lining. So the reason for that is that you want the needle to spend less time on the skin. Really, that's what it ultimately comes down to. Because if I'm tattooing, and like we described in this other previous video, we're always going in at an angle, right? So that the needles need to get in, get out before my hand moves forward. Otherwise, you get this like catching sensation. What do they call it? Catching?
Yeah, snagging or whatever.
Snagging, right. So you're kind of like pulling and snagging and potentially creating tears rather than holes. And like we had said in the previous video, holes suck ink in, tears don't really, not nearly as efficiently. So you want holes. Now, one thing I thought about that I don't think we mentioned in the previous video is and some people, I think they do this because I don't know that they're connecting why they're doing it, but if you line backwards, you fix the problem. Because now picture it this way. You're poking the needles in and you're not moving forward, you're actually moving this way. So if you were to prematurely move forward before the needles were extracted, it's more like, the needle's going to come out easier versus this like forcing it that direction. So if you want to solve the problem without trying to find a machine that will solve it for you, just tattoo backwards.
The only thing I can think of is, I remember thinking, this is back when I first started tattooing, we're using traditional tubes and needles, is that you always wanted the needle, down in the bottom of the tube so that you were getting like a consistent ink flow. And if you were pulling backwards, you may pull the needle from the, and disrupt the flow of ink. Yeah. But yeah, I get what you're saying.
No, that's a good point. Yeah. So with a rotary, you want a stroke length that's longer because then it spends less time in the skin relative to its cycle. So if, let's say this is 5 millimeters and the needle is traveling, let's say we're poking to a depth of 1 millimeter. So that's about like this much of the 5 millimeters. So the needle has to spend the time it takes to get there, first of all, then it does the poke and remove. And then it spends the time to get all the way back and then spends the time to get all the way back again and then poke, remove. So most of the time is spent in this back section and the poking happens only in this front section. Now, the downside to that is that because it's a rotary, again, like the shape is a perfect circle. And so the speed, if the needle's going this way, the speed is right here and right here. That's when the needle's moving as fastest. When it's here, it's crossing over. So if you're like looking at the bottom of this pen, like while it's going here, it's really not going up or down. It's just crossing over. When it gets here, then it starts to move fast in that direction. And so if this is a 5 millimeter thing and all of your poking happens in that little section of it, you can see that most of that is the slow section of the cam. And the longer the stroke, the more exaggerated that point I'm making becomes. And so what that basically translates to is your needle goes really fast here and then slows down and then slowly comes back and then really fast here and then slow, and then fast and slow. So you're losing, like especially when you're lining, you really want impact. You want it to hit hard and then get out really fast. What a long stroke is actually doing is it's hitting soft because it's slowing down before it hits, and then it hits, and then it slowly gets pulled out. So it still has all that dwell time, although I would say that it does still work better than a short stroke rotary. But ideally, what you really want is a rotary that the needle strikes in the speed zone, not in the slow zone.
I don't know how much you know about rotary motors. I don't know a ton, but I wonder if there's a way. I mean, I know there are multiple windings, and I think the more that you increase the number of windings, the more you could probably keep momentum more stable. Does that make any sense? Like, is there a way? Could you design a rotary motor that fixed that problem?
Well, I mean, that's what I believe that my product is all about. Is so it's the cam is designed so that if this is a needle, it's cycle, half of its cycle. If this is the skin and the needle is back, half of its cycle it just sits here waiting, and then the other half of the cycle it does both. So what that kind of does is it removes 50% of that slowing down hesitation stuff in the extended position. I don't think that it's possible to completely remove it because the geometry is just too challenging. I've done it actually with experimental cams, but they don't last. They beat the crap out of motors, and they just burn out really fast because the geometry, it's like almost like a little ramp, and in order to get it to return in the same way that a coil does, you have to put so much down pressure from a spring that you're wearing everything out really quickly. Not only that, I've found that it's not necessarily the ideal situation anyways. In fact, so for example, like the one cam that I designed for lining actually ended up lining better than the one where I forced it to come back even quicker. I'm not sure why. I think it's kind of like the conversation we had with Ty about hole size. So you do want your hole to be big enough to make a good mark, right? And maybe that's what it is.
I thought about this when I was going through and listening to our episode earlier today. Is there ever a situation where you would want to increase either increase the amount of time in the skin, I know a few of your cams have a slower and softer insertion and then a faster, pullback. Is there ever a situation where you want to increase the dwell time in the skin or change how quickly it gets in and out? Or do you always want the needle to get in and out as quickly as possible?
Yeah, no, not always. I think that slower ones work really well first of all, your hand speed is going to play a part. So if you're moving your hand really fast, you want it to get out really fast. If you like to move your hand slower, then you can get away with using a slower cam, and it might actually help you. What I've found is people who do a lot of dot work, that they have a very rhythmic way of moving their hand, and that works better with a slower moving cam versus the really fast one. Or like black and gray stuff. If you've seen some of these portrait guys that they have this very rhythmic way, they're barely touching the skin and they build up over time. I think the slower moving cams work better for that as well. Yeah.
Okay. And the slower moving cam, is that typically just on insertion or I
have both. So two of the cams that I make are asymmetrical, so that they slow down the insertion but maintain the quick recoil. Mm-hmm. Like one is slightly slower and one's much slower. And the philosophy behind that would be that the poke is what is causing the hole. So it doesn't necessarily need to hesitate in there. Once it's made its depth, get it out. I also have one that is just like a standard rotary that will go in at the same speed as it recoils, and it's as slow as it gets, right? Or as slow as I make it. I mean, I could technically, in the same way that I have a flat spot in the back of the cam or in the recoiled position, I could make that in the extended position, right? So it just waits there for 50% of its cycle, and it does the out in half this,
Yeah.
Maybe one day I'll do that just to try it out, but I don't know.
Yeah.
Well, just to try it out.
Yeah, I would be curious. This is a little bit off topic, but how easy is it for you to test that? I mean, is it a huge effort for undertaking for you to do?
It's just making it. Not really. It's just making a new cam. It has to be designed in the computer first, which isn't a big deal. And then it's really more about getting the manufacturer to make a prototype, basically.
Gotcha. And they're actually machining the
prototypes. So now I'm making them like a blank. So this one doesn't have the ramp in it, and then I'll go in later with a machinist, and they machine out the ramp.
Okay.
So now it's a lot easier to make a prototypes. I don't have to make the whole thing, but we still have to design it.
Right. Okay. What made me ask that is what popped in my head when we were talking, or when I was listening to our last episode, was I was like, well, if you slow the machine down and you increase the dwell time slightly, maybe you make a little bit larger hole, and maybe if you're trying to get solid color, you might want that little bit larger hole, and then if it retracts quickly and the vacuum pulls the inks in. But then I thought, well, if you want a larger hole, then you just change the size of the needle that you're using, right? I mean, or the taper or whatever else. And it seems like even still, you could insert and recoil as quickly as possible, and then let the shape of the needle determine the size of the hole.
I'm sure there's some variable that we're not aware of. That's the thing about this stuff. It's maybe even the stuff that you really don't think would be a good idea at all could turn out to be something great. Right. So I would say it's probably worthwhile to explore the possibility.
Yeah.
So there's something that we're not thinking about. We're thinking in terms of something where we've never done it before. We don't understand it entirely. So.
All right, let's call it there. Hopefully I can dodge the thunder again. So that's it for this episode. Like I said, I'm trying to keep these things manageable. Next time, we're going to introduce a new variable, which is voltage, power, and how that plays a role, or what role that plays in this whole rotary kind of equation that we've introduced here. We're all going to be rotary gurus by the time this is over. I hope you enjoyed that episode. Again, support us by supporting our sponsors. There's the thunder. I didn't make it. Support us by supporting our sponsors. The links are below. We are trying to work with sponsors who are just who are not only benefiting the tattoo world, but that are just good people. And I think all the folks that are sponsoring us right now are just really good people to be associated with. So thank you guys, as always, for supporting the Fireside Tattoo Network, and we'll catch you next week where we continue this conversation talking about voltage and power and rotary tattoo machines.